Ever feel like you need, like, a computer science degree just to get what makes Rust so different?
Hmm.
We're going to dive deep into this really cool thing with Rust memory safety.
Okay.
And we've got this Medium article. It's called A Simplified Comparison, Rust and Pointers
Okay.
by Anohu Ab1R. And they explain it really well, even if you're just, starting out with Rust.
Yeah, for sure. And it's something that can be intimidating when you're first getting started, but the way they lay it out is really approachable.
Totally. Like, I love how they start with this whole apartment building thing for memory.
Yeah.
It's like pointers suddenly make sense.
Yeah. Yeah, it's a good analogy to kind of wrap your head around.
Instead of these cryptic things, they're just apartment numbers.
Exactly. It
Yeah.
makes it much less like mystical,
Totally.
you know?
Yeah. So speaking of a well-run building, the article goes straight into Rust's ownership paradigm.
Right.
It's like this super organized landlord for like our memory apartment building, right?
Yeah. And that gets at why this is such a powerful feature of Rust. Because like if you think about traditional languages like C++, where you can get into a lot of trouble if you're not really, really careful
Oh, yeah.
about allocating and releasing memory, you end up with these memory leaks, which is like leaving the faucet running in your apartment building.
Oh, no, not the water bill.
Yeah, exactly. And so Rust is designed to prevent that from happening in the first place.
Wow.
It's really about kind of like Rust says, hey, you brought this memory into the building.
It's your problem.
You're
And you're
responsible.
responsible for
You
it.
brought it in, you take it out.
It's like no leaving a mess for someone else to clean up.
Yeah, exactly. You got to clean up after yourself, which is kind of nice, I guess.
It is nice, actually.
Yeah.
So we've got like a responsibility. What about if you need to use something temporarily?
Right. That's where borrowing comes in.
Okay.
So borrowing is kind of like the temporary keys to our memory apartments.
Okay, I like that.
And so the article kind of breaks it down into like you've got your immutable references,
Okay.
which are like if you borrow a book from somebody.
Right.
And then you got mutable references,
Okay.
which are more like if you need to edit a shared document.
Okay.
But of course, Rust, like the kind of ever-vigilant landlord, has ground rules
Right.
to make sure that you don't get any conflicts.
Of course, yeah.
You can have multiple people borrowing the book, that's fine, but only one person can have the editing pen at a time,
Right.
to stretch this analogy.
Yeah, no, it totally makes sense.
And that prevents these things called data races, which you might see in other languages, where if you have multiple things trying to access and modify the same piece of data at the same time, it can cause all sorts of problems.
Wow.
Yeah.
So Rust is like taking care of all that for you.
It is. It's doing a lot of that work behind the scenes for you at compile time, which means it catches those potential errors before your program even runs.
Oh, that's great. So you don't have to worry about it later.
Exactly. It's like having a building inspector who goes in and checks for all the potential problems before anybody moves in.
I like that. That's a good analogy. Okay, let's talk about smart pointers for a minute. This is where I think about like the building management office.
Yeah.
There's all these different personalities.
I like that analogy, yeah.
Like there's box T, which is like the super organized one. Like they make sure everything is neatly stored away.
Exactly. They allocate memory on the heap and they give you a pointer to manage it.
And then you've got RCT, right? Which I
Right.
think of as the friendly manager who handles like the shared storage units.
Yes. RCT is all about like shared ownership.
Right.
So you can have multiple owners for a piece of data.
Mhm.
It keeps track of how many references there are and make sure everything gets cleaned up properly.
Oh, that's nice. So it's like they've got that whole system for like signing things in and out.
Yeah.
Exactly. Yeah, it's very organized. And then there's RefsLT,
Okay.
which is kind of like the I'm trying to think of a good analogy. It's like the person who's like really strict about the rules, even when
Even when things get a little crazy.
even when things get a little crazy. Yeah,
Like during a fire drill and they're like, "Do you have your ID badge?"
exactly. Yeah, RefsLT is like that extra layer of security, making sure that even though the program is running and things might be changing, that you're still allowed to access and potentially modify the name.
Right. So it's all about maintaining order even when things are a bit chaotic.
Exactly.
Okay, so we've got our apartment building, we've got our organized landlord, that's Rust. We've got our building management team, the smart pointers. But then like the article mentions lifetimes, and I gotta say that's where I had to like reread a few times.
Yeah, lifetimes can be a bit tricky to wrap your head around at first.
Yeah, a little bit.
But think of it this way. Lifetimes are Rust's way of preventing squatters.
Okay.
Like, you wouldn't want someone trying to live in an apartment that's already been like demolished, right?
No, definitely not.
So lifetimes are how Rust makes sure that every reference you have is actually pointing to a valid piece of memory. It's a system for preventing these things called dangling pointers,
Dangling pointers. Okay.
which can cause all sorts of problems in other languages.
Right. Yeah.
And the article gives this code snippet. Let me see if I can pull it up here.
Yeah. Yeah.
Here it is.
Okay. I see it.
Okay, so it's basically Rust is checking everybody's keys to make sure that they haven't expired or that they're not for a place that doesn't exist anymore.
That makes sense.
So to illustrate this, imagine you have a function that takes two references as input. Now, this function is supposed to return a reference to the longer of the two strings. But what if we pass it a reference to a string that's created inside the function and then goes out of scope? That's where lifetimes come in.
So it's like trying to give someone the key to an apartment that's about to be torn down.
Exactly. Rust steps in and says, nope, not going to happen.
It's not safe.
Not on my watch.
And this might seem a little overly cautious at first, but all of this, these checks and balances, are what make Rust so powerful. And it all ties back to this idea of zero-cost abstractions.
Okay, break that down for me. Zero-cost abstractions.
So it means that you get all this memory safety without sacrificing speed or efficiency. Rust isn't constantly slowing down your program with garbage collection like some other languages might. So you get the security without the performance hit.
Exactly. It's like having a super efficient building manager who somehow never sleeps and is constantly making sure that everything is in order, but you never even notice that they're there.
I'm starting to see why people are so excited about Rust, I gotta say.
It's really cool stuff. And this whole trend towards languages that can give you both low-level control and high-level safety, I mean, we're seeing this more and more these days.
Yeah, it seems like it.
And as software just keeps getting more and more complex, security and reliability, those are non-negotiables.
Totally. Yeah,
Yeah.
it's like we can't keep building bigger, more elaborate buildings if the foundations are shaky. We need something robust, something reliable. It's like, with great power comes great responsibility, right?
Absolutely, yeah. Rust really takes that to heart.
They really do, especially when you think about, like, memory management.
For sure. And, even if you never end up actually writing Rust code,
Yeah.
just understanding these core principles, I think it makes you a better programmer in any language.
That's true. Yeah, it's about understanding the tools even if you don't use them.
Exactly. It's like you might not paint like Picasso,
Great.
but understanding his techniques can help you appreciate other art forms even more.
Totally. So speaking of different approaches, like, our article author didn't really get into, like, potential downsides of this whole Rust strictness thing.
Yeah.
Is there a trade-off we should be aware of?
Right. And it is important to acknowledge that no language is perfect.
True, true.
And Rust does have a learning curve. It can be a little steep, especially for beginners. Those ownership and borrowing rules, they're fantastic, but they can feel pretty restrictive at first.
It's like a super organized landlord who's like, let me see your grocery list.
Yeah, exactly. Like, hold on, I need to approve all of your purchases.
Uh-huh.
But there's a reason for it.
Right, right.
It's like it forces you to think differently about how your code is interacting with memory.
Interesting.
And that leads to more robust software.
So it's an investment up front, but potentially a huge payoff later on.
Exactly, yeah. It's like learning a musical instrument.
Yeah.
It takes time, it takes effort to master, but the results are so rewarding.
That's a good way to put it. I feel like this whole deep dive has given me such a new appreciation for, like, what's going on behind the scenes of the code that I write.
Yeah.
Things that I kind of took for granted, like, how memory is managed and all that. Right. It's
Yeah.
like, wow, this is really important.
Yeah, and it's like once you start to see those things, you can't unsee them.
Totally.
And it makes you a better programmer overall.
Absolutely. Well, for our listeners, if you've enjoyed this deep dive into memory management and you're curious to learn more about Rust or even just how your language of choice handles these things,
Yeah, definitely.
keep those questions coming. And until next time,